No worries. And thanks to everybody who volunteered me for my second stint at ComfyCon. It's great to be back. And thanks to everyone who's tuning into this session, which is on decoding infrastructure as code security. So where this session came from was over the past couple of years, I've been working on a lot of cloud infrastructure projects, and a common challenge which I run into when working alongside other security people is that most people come from working in on-prem backgrounds, and they apply the same on-prem mindsets to the deployment of infrastructure in the cloud. So as someone who's come from an on-prem infrastructure background myself, I've been looking for ways to help other security people uplift their knowledge of cloud native infrastructure. But before we get started, a quick intro so you get to know who I am. My name is Bronwyn Mercer, and I work as a security architect at Microsoft, working in our consulting services team. So as part of my role, I get to design and build cloud solutions for organizations all around Australia. And I've been working in IT for about 10 years now, starting out as a sysadmin, and then I moved into various different security roles, including security as a security analyst and working in GRC. And in my spare time, I spend a lot of time volunteering in the community. I'm really passionate about diversity and inclusion, and I'm also a AWSN Sydney chapter lead. And last but not least, I'm also a Twitter lurker, although I'm not sure how much longer that will last. Maybe I'll be a Mastodon lurker next, who knows? So that's me. So what's in it for you as part of this session? So as part of this session, I'll be covering some infrastructure as code concepts. So I want to lay the foundations if you're not familiar with the topic. I also want to share some of the security benefits of infrastructure as code, and then share some common vulnerabilities in infrastructure as code technologies and processes. And lastly, I want to share some practical security strategies which you can apply to your infrastructure as code solutions. And my goal for this session is that whether you're a builder or an architect or even a GRC person, you'll be able to integrate security into your development and deployment processes. And hopefully this will prepare you a little bit more for the world of cloud native infrastructure deployment. So in my experience, there's two types of people: those who build cloud systems in the GUI or the portal, and those who build systems using code. And up until about a year ago, I was firmly in the first category. It wasn't until one particular project that I was forced to admit that my approach wasn't really fit for purpose in today's constantly changing environment. So just to provide some background, I was asked to come in and help an under-resourced project to design and build the security controls for a system which integrated lots of different data streams. So it was taking data and then sending data out to the right place. So I was asked by the project team to come in and design the system and create a proof of concept in Azure. So I used the GUI, built the solution, demonstrated it to the customer. Everything was good. And so next, the project team asked me to translate that solution into a test environment, a perf environment, and eventually a prod environment. So unfortunately for this solution, we didn't do integration testing until quite late in the process. So now the team was ready to test the integration with all of those different data sources. And it was only then that we realized there was a major issue with the networking in the solution, which meant that all of the infrastructure needed to be redeployed. And at this point, I was kicking myself because of the way I had deployed the solution. It meant that I had to do all of those redeployments manually. And so the lesson learned, this was really a game changer for me because it made me realize it was time to learn infrastructure as code and to think about reusability from the very beginning. So how would infrastructure as code have helped me with this project? So during the early phases of a project, when the requirements are still unclear and integration hasn't been tested yet, there's usually a lot of change. So we need to use an approach which provides us with flexibility. The whole premise of infrastructure as code is that we define the requirements upfront in a config file, and this is used as the single source of truth for deploying all of the infrastructure components. And this means that if requirements change, as they usually do, like for example, maybe we need 2 servers instead of 1, or we completely change the type of storage in the solution, all we have to do is update the config file, and that change gets rolled out into the environment without any manual effort. It also means that if additional security requirements come along, so for example, no public internet access, we can easily integrate those controls into the solution. And this is pretty common as part of an agile deployment methodology. So using this approach has a lot of benefits because we have consistency, reusability, and an evolvable design. So we're basically intentionally building systems with the idea that the design will change, it will change over time. And if something changes, we update the source of truth and then we just rebuild. And from a security perspective, this also has benefits. So it has benefits like we can bake in security and compliance from the very beginning of the development lifecycle. We can also translate those security requirements into code, and we can enforce compliance with those requirements using automated processes. So it's important to note that infrastructure as code includes both technology and process components. So it's underpinned by DevOps processes for designing, building, and managing any cloud infrastructure. So you might have heard of those kind of DevOps processes. And on the tooling side, some of the common tools you'll see are things like code repositories, CI/CD tools, config management tools, orchestration and provisioning tools. We use these tools to manage templates and images for the infrastructure we want to deploy. On the template side, I put some of the icons of some of the common template providers. And so they can be loosely divided into provider specific. So things like Bicep and ARM for Azure and CloudFormation for AWS. And then you've got provider agnostic languages like Terraform and Pulumi. So on the right-hand side, you can also see an example of a Terraform template for an Azure storage account, which contains the customizable parameters like the name, location, and the tier of the resource. It's also important to understand that the approach of using templates to deploy environments falls into a declarative programming paradigm. If you don't have any background in programming, programming in general has 2 main paradigms, imperative and declarative, where the imperative paradigm talks about the how. So in that paradigm, we define the commands that are needed to deploy a specific configuration, whereas in a declarative paradigm, we talk about the what. So in that approach, we basically define the state of the system and we leave the steps about how it's implemented to the computer. So I'm primarily going to be focusing on the declarative paradigm in this particular session, although you can also deploy infrastructure using imperative type commands as well. So for example, using the Azure or AWS CLI, and that will allow you to deploy systems. But most people would prefer a declarative approach because it provides a lot more repeatability and flexibility in the way you'll deploy your infrastructure. So I've talked about the benefits, and there's quite a few benefits of using infrastructure as code, like embedding security in the infrastructure development process. But like any technology solution, infrastructure as code can also introduce vulnerabilities if it's not managed correctly. So a lot of people who are using infrastructure as code, they like to source their modules, their images, and their software libraries from public repositories. And I recently came across some interesting research from Unit 42, which is Palo Alto's threat intel team, about the state of cloud security. So they produced some good research-backed analysis into infrastructure as code security as well specifically. And some of their findings were that From analyzing over 4,000 Terraform templates and over 38,000 Terraform files in open source repositories, they found that 63% of the Terraform templates contained one or more insecure configurations. And what you can see on the right-hand side of this slide is that there's different categories of vulnerabilities which were found in those templates which were scanned. And some of the common misconfigurations were things like encryption, logging, and networking. So pretty important things. And in addition to that, the researchers also analyzed over 1,500 container images from public registries like Docker Hub, and they found that 91% of the images contained critical or high severity vulnerabilities. So that really highlights the severity of vulnerabilities that are out there in those open source repositories, which people are using to build their infrastructure. And what can happen is that we can end up building infrastructure that's really insecure because you have the cumulative vulnerabilities in the templates you're using to define the infrastructure, the images you're using to run the operating systems on that infrastructure, and then also the open source libraries and packages that you're using to run code on that infrastructure as well. So those layers of vulnerabilities can start to stack up from the very start. So we talked about some infrastructure as code concepts, and I hope now that you have a bit of an understanding of the benefits and also some of the vulnerabilities to look out for. So what happens if you need to deploy a system quickly and securely using cloud native technology, like I did with my proof of concept. So I'm going to cover a few tips to help you to secure your cloud infrastructure. But before I get into the main recommendations, I want to set up a framework for thinking about infrastructure as code security. And the first piece that I think about when I think about the development and deployment of infrastructure as code is the process component. So that's your coding, your building, deployment, and operations, which is like your classic DevOps process. The second piece that I think about when I think about infrastructure as code security is the technology. So that includes the platform that you use to manage your code, to create your pipelines, and also those infrastructure as code assets like your templates and your images, which are being deployed into usually a cloud environment to deploy your infrastructure. So this is how I think about a framework for infrastructure as code security. So now I'm going to go into a bit more detail about some of the specific controls. So the first is setting some ground rules, and I wouldn't be an architect if I didn't talk about governance. So let's go into some governance. So if you're thinking about using infrastructure as code, we need to think about security by design, which means that we need to have an awareness of things like security and compliance requirements. Does your industry have specific security requirements you need to think about? Do you have a cloud deployment framework which specifies certain naming and tagging standards? That can be really important in helping to prevent ghost resources from floating around your environment. And thirdly, what's your cloud operating model? Which teams are responsible for maintaining your platform versus application components? So what I've seen is that if you don't do the work upfront to lay the foundations, it will be chaos when it comes to operationalizing your systems. So this foundation of governance is super important. I guess part two of the foundation is the secure platform. So we want to make sure we have things like a secure repository, secure build infrastructure, and then also, I guess one of the benefits of infrastructure as code is that we can translate those security requirements we identified earlier into policies which enforce the secure configurations from the very beginning. So I've just put one example here, which is Open Policy Agent, which is an open source example of a policy engine which you can use to create those policies. The second recommendation I have is secure the infrastructure as code supply chain. So I was talking about vulnerabilities earlier, and I mentioned this kind of snowball effect of vulnerabilities adding up in your templates, your images, your packages. You might have heard people deploying images that contain Bitcoin miners, and then, they're running Bitcoin miners in their environment. The same thing goes for your images that you use and your templates that you use when it comes to infrastructure as code. So we want to make sure that we use images and templates from trusted repositories. And then in addition to that, we want to trust but verify. So make sure that those templates are secure before deployment. So that means using some kind of static code analysis type of tool. So there's just a few examples of those kind of static code analysis tools that you can use. There's a lot of open source tools out there that you can use to look for template misconfigurations, look for credential exposure, and identify vulnerabilities in open source libraries and packages. So that I've just put a few here, and in particular, I've come across Chekhov a lot in different enterprise customers' environments, and that is a really interesting tool that allows you to look for those template misconfigurations before you deploy infrastructure into your cloud environment. So my third tip is keep your secret secret. I don't know if you've noticed, but there's a scourge sweeping the land, and it is the scourge of exposed secrets. And by secrets, I mean encryption keys, SSH keys, authentication keys, API keys, etc. But if you've been following security news over the past year, you've probably seen a few breaches caused by the Lapsus group, who stole a bunch of source code from companies like Samsung and NVIDIA, and they posted that code online, which is not great for those companies. But on the plus side, a bunch of security researchers have been able to analyze the code from those code dumps, and they found some really interesting things. So, for example, in the case of Samsung, the security researchers found 6,600 keys in Samsung's source code. Most of those were for internal services and infrastructure, but 10% were for services like AWS and GitHub. So imagine you're an attacker, you've got this source code with all these plain text keys and secrets. That allows you to access other things and make the breach scale even larger. So the recommendation here is that make sure that secrets and keys are always vaulted. Even if your code is only internal facing and you think nobody's going to ever get their hands on this, always put your secrets in a vault, and just refer to that secret vault in your infrastructure as code templates, and that will then feed those secrets into the build and deployment process. It's no excuses. So my fourth point is monitor for drift. So we've got some resources deployed and they're running. Now we need to make sure that those resources remain consistent with what we deployed via the infrastructure as code templates. So there's a couple of risk scenarios I want to highlight. The first is you've got an attacker and they make a change to a master copy of one of your modules. And since we're using declarative code, which is defining all the specifications up front, that misconfiguration of your master copies of your modules can lead to widespread misconfiguration across your environment. So, for example, setting network interfaces on servers to public means that your servers are now publicly exposed. The second risk scenario that I want to highlight is somebody makes a manual update to the configuration of resources which have been deployed. And this means that those deployed resources are no longer consistent with what's defined in your templates. So your code scanning tools, your static code scanning tools are not going to pick up that misconfiguration. So how can we address configuration drift? There's a couple of ways. The first thing is continuous monitoring. We want to make sure we have audit logging enabled on resources, automatically integrate any deployed resources with your centralized logging and monitoring tools. So they're getting that telemetry is automatically being sent without any manual intervention. Make sure you lock down manual edit access directly on resources so that people aren't making those out-of-band updates. And if someone does edit those resources directly, make sure you redeploy them from the standard infrastructure as code template. The second piece is Make sure you monitor your cloud security posture to detect misconfigurations, especially for the second risk that I mentioned before. People joke all the time about exposed S3 buckets and storage accounts, but you do need to monitor your cloud security posture as a whole. And you can use tools like CloudSploit and Scout Suite. I put a few tools here which you can use, which allow you to scan the security posture of your overall cloud environment and find resources with insecure configurations. And that will help you to identify resources that are not aligned with your templates and your policies, and then hopefully take some corrective action. So I'm getting towards the end now. So just to wrap up and summarize, I've covered 4 main areas for securing infrastructure as code. Set up secure ground rules. Don't skip the governance. Secure the infrastructure as code supply chain. Keep your secret secret and monitor for configuration drift. If you implement all of these controls and concepts, you will be well on your way to being a master of secure cloud infrastructure. And thanks a lot, and happy to take any questions.